Okay, so one of the things that we talked about is when you integrate a function and you substitute the limits in, what you get is the area under the curve between those two limits. Okay, so here in this question, okay, so I've got a cubic. What this will do is it will give me the area between 1 and -2. Okay, so that's 1 there. Now, one thing you should be aware of is above the x-axis, the area is going to be positive. Below the x-axis, the area is going to be negative. So I can't actually do it just one in one go. I have to separate it. So what that means, I have to separate it to 1 and 0. Okay. And then add the positive value of integrating from 0 to -2. Okay, so I hope that makes sense. So because area under the curve is negative and area above the curve is positive, if I just kind of substitute 1 in and then take it away from -2, some of this area will cancel out this area and the answer won't actually be, you know, the correct answer. So you have to take them separately, and area is positive. So even when it's under the curve, you will get a negative value, but what we do is we take the absolute value, okay, because area is positive. Okay, so hopefully you're okay with that. Now, if you have any questions, let me know. So if we're looking for between two curves, okay, so when I integrate and put in limits, so if I integrated the blue function, I will be getting all of that area, okay? But if I just did the red one, this is the area I would get. So if I subtract one from the other, then I will get the area in the middle, okay? So what you need to do when you're trying to find area between two curves is, first and foremost, figure out which one's the top curve and which one's the bottom. So the one at the top here is the top, and the one here at the bottom is the bottom. So you go top function, take away the bottom function, and then you integrate and you substitute your values in. So or the limits will be the points of intersection. So those two are your points of intersection. And that's where the limits are. Okay, so that's just a brief overview, and I'll do a question so you guys are feeling comfortable and you know exactly what to do. Okay, so let's do this question here. Okay, we'll do question 3. Oops. Okay, we'll do question 3. So now first thing I need to do is figure out which is the top function. That's easy enough because they've already drawn it for me. So that is y equals e to the x, and the bottom is y equals x. So I'm going to have e to the x minus x. Okay, and they've actually given us the limits. It's not where they intersect, it's 2 and 0. So I'm going to write down 2, 0. Okay, and that's what I'm going to do, integrate this. So when I integrate e to the x, the integral is itself, and divide by the derivative of the power, which happens to be just 1. And then that will be x squared over 2. Okay, now the limits are 2 and 0. So I'm going to substitute 2 in. So e2 minus 2 squared over 2. Okay, take away e to the 0 minus 0 squared over 2. Okay, so the e to the 2, I don't know what it is, I'll have to use my calculator. 2 squared over 2 will be just 2, and that's minus 1, e to the 0 is 1, and 0. So basically what I have is e to the 2 take away 3. That's my final answer, square units. Okay, so that's what we do. So are you okay with how to find area between curves? Actually, before, if you were doing a question like this, so you'll see the limits are not given. So what you have to do is actually find the limits by finding the points of intersection. So you do x squared equals x, and then x squared minus x equals 0. We can factorize it. So you get two solutions, x equals 1, which is that one, and x equals 0, and those are your limits. So you do the same process, but there's the extra step of where you have to find the intersection points to get your limits. Okay. Yes, let's go through that again. Okay, let's do this question here. So what I'm trying to do is find the area between this line and that line, or that curve. So this is the area I'm looking for. Okay, so when you're finding area between curves, the first thing you want to do is figure out which one is at the top and which one's at the bottom. There's two functions, right? One is y equals x plus 2, and the other one is this. So which one is at the top, which one is at the bottom? So the area where I'm looking at, okay, so that line is at the top. And then this curve is at the bottom. Okay, so from that I will get x plus 2, because that's at the top. So you write the top function first, minus the bottom function is the curve. So okay, and okay, the next bit is I need the limits, or that point and that point. This one we can actually see that the one of the limits is x equals 3, so I'm going to put that in, and you can see the other one is 0. Okay, so sometimes that's not clear. Sometimes you actually have to work it out. So it might be in situations like this where you have to find the points of intersection. All right, now, so what we're then going to do is integrate like normal. So I'll rewrite this first. So x plus 2 minus x squared plus 2x minus 2. Okay, and I'm going to simplify it more. So that's going to be, sorry, I'm going to try and write better. That writing is terrible. So got x plus 2x, so that will be 3x. And plus 2 minus 2, they will cancel out. And then I've got the minus x squared. Okay, so I'm integrating this. So that's when I integrate, I will get 3x squared over 2, and that's x cubed over 3. And my limits are 3 and 0. Okay, so what I'm then going to do is substitute those values in. So 3 times 3 squared over 2 minus 3 cubed over 3. Okay, that's me substituting 3 in. And I'm going to take away from substituting 0. So that's just going to be 0, I can see. So that is 27 over 2 minus 9, which is 13.5, take away 9, which is 4.5. Okay, so just to summarize again, when you're finding area between two curves, okay, the first step is to figure out what's at the top. So that was my top function. Okay, when it's sometimes people have trouble understanding, what do you mean by top? So when I have the graph, so this, the part where I'm looking for the area, okay, that line is above the curve. Okay, so that is the top function. This curve is underneath. Okay, so that's the bottom. So this is your bottom. Okay, so you go top, take away the bottom, and your limits are these points here. Okay, either it's clear from the graph or you have to work it out by finding points of intersection. Then once you've done that, you're just integrating it, substituting the limits in to work out your answer. Okay, so does that make sense, guys? Cool. Okay, I can see some thumbs up coming up. That's good. All right, now, so if you're happy with that, then I'd like to move on to the next bit, which is finding the constant of integration. Okay, so, okay, now here we have, let's just look at this example here. So it says, find f of x if f dash of x is 12x plus 4 and f of 1 is equal to 2. So you have been given the derived function, which is 12x plus 4, and they're asking you to find the original function. And they've given us some condition that helps us find out the constant. So what I want you to understand is this notation, f of 1 is equal to 2. So what it's saying is when x is 1, y equals to 2. Okay, so that should go in there. So when x is 1, y equals to 2. So the first thing, what we're going to do is we're going to anti-differentiate. And so I've got 12x plus 4. So when I integrate that, that's going to be x squared, and I'm dividing by 2, so that's 6x squared plus 4x. And then let's not forget our constant of integration, which is just c. So what we're trying to do is we're trying to find, this is the general antiderivative. We want to find the particular one, so the exact one. So the condition is when x is 1, y is 2. So let's substitute that in. So 6 times 1 squared plus 4 times 1 plus c is equal to 2. So 6 plus 4 is 10 plus c equals to 2, which gives us that c is negative 8. Okay, so when I write out my function, I will get y, or you can write f of x, 6x squared plus 4x minus 8. Okay, now sometimes you might have something like a second derivative. So like in this question, they've given you the second derivative. When that happens, they'll have to give you more than one condition to be able to help you go back to the original. This generally happens a lot with kinematics. So kinematics are things like where you might be given acceleration and they'll give you some thing about the velocity, and then they'll ask you about displacement. Okay, so we'll just go over one of those examples as well. So you've got the second derivative. So let's integrate that first, which gives me x squared, and I'm dividing 8 by 2, so it's 4x squared plus 6x plus c. Now what I have here is f dash of x, because I integrated f dash dash x. Now I have a, if you have a look, I know that f of 0 is 2 and f of 1 is 8. Okay, I can't work out what c is just yet. So what I will now do is integrate this again, which will give me x cubed 4 over 3. Oops, I don't need this. I don't want that. Okay, plus 3x squared plus cx plus, I'm going to have to use c1x here and c2 because they're different numbers. Okay, so now I'm going to have to work out what c1 is and what c2 is. So I've got two conditions. I'm going to substitute them. What I'll end up with is essentially a simultaneous equation where I can work out what c1 and c2 are. So 4 over 3 times 0 cubed. So here I'm using this when x is 0, y is 2, plus 3 times 0 squared plus c1 times 0 plus c2 equals 2. So basically I've worked out that c2 is equal to 2. Okay, so I've got 4 over 3 x cubed plus 3x squared plus c1x plus 2. Okay, now I'm going to substitute when x is 1, y is 8. So 4 over 3 times 1 cubed. and 3 times that plus c plus 2 is equal to 8. Okay, so when I simplify that, that's 1 1/3. It's not writing. Just have it there. Oops. Okay, so I've got 1 1/3 plus 5 plus c equals 8, which basically gives me 6 1/3 plus c is equal to 8. So c is 8 take away 6 1/3, which is essentially 1 2/3. Okay, so I've got my equation. I'll write it up here at the top. 4/3 x cubed plus 3x squared plus, I'm just going to write this as an improper. So that's 5/3 plus 2. So that is your f of x. Okay. Now, as I said, the area where this comes in a lot is essentially when you're doing kinematics. So let's remind ourselves. So when you differentiate distance, you get velocity. And when you differentiate velocity, you get acceleration. Okay. And okay, here we go. The things that you should be aware of when it says initial, okay, initial implies that t is equal to 0. And if it says stationary, that means velocity is 0, okay? And so you might have a question like this. Missile is accelerating at a rate of 4 t meters per second squared from a position at rest. Okay, let me move this down. In a silo 35 meters below ground level. How high above the ground will it be after 6 seconds? So what you've been given is acceleration. Okay, so A is 40 meters per second squared. Now from a position at rest. So when we're talking about rest, again, velocity is 0. Okay, in a silo 35 meters below ground level. Okay, so we have been given that distance is when t equals 0 is 35 meters below. So what that means is d is negative 35 when t equals 0. Okay, so once we have all of this information, we have to try and work out the function for displacement and then what it will be after 6 seconds. So let's start by integrating acceleration. So when you integrate this, you get 2t squared plus c. That's your velocity. Okay, so we are told v is 0 when t is 0. Okay, so from a position at rest. So that means when time 0, v is 0. So we end up getting v is 2t squared because v is 0, t is 0. Now, the next step, I'm going to integrate this to get what displacement is. So that will be 2/3 t cubed plus c. Okay. Now what we're going to do is substitute the negative 35 when t is 0. So that will just give me 2t cubed. So this is my displacement function. So, and they ask you what it will be after 6 seconds. You just substitute t equals 6 and work out what that will be. Okay, so when t equals 6, 2 times 6 cubed over 3 minus 35. Okay, so I will need to use a calculator for that. Okay, so we have 109. So it's going to be 109 meters above the ground. Okay, so let's have a look. Let's stop.